Today let us start with module 3, LTI system properties in terms of impulse response. LTI system properties in terms of impulse response. In that, first topic is system interconnection. First case is in case two systems are connected in cascade like this. H1 of t and H2 of t, let it be the two systems which are connected in cascade. Cascade connection is nothing but one system output is given as the input for the second system. So H1 of t output is given as H2 of t as the input. Now these two are connected like this, H1 of t and H2 of t, where x of t is the input, y of t is the output. These two systems, whatever the H1 of t, H2 of t there, that can be simplified as H1 of t convoluted with H2 of t. And where the output y of t is nothing but H1 of t convoluted with H2 of t, and these whole convoluted with x of t. Now the second case where the systems are connected in parallel. Let us take H1 and H2 are two systems which are connected in parallel and these two are connected given to a summer. X of t and y of t are the output. Then these, whatever this entire system is there, can be written as H1 of t plus H2 of t. And the output y of t is nothing but H1 of t plus H2 of t convoluted with x of t. Let us take another case which is a combination of cascade and parallel. Here if you see, H2 of t and H3 of t are connected in parallel. H of t is connected to this parallel combination. So let us take this entire whatever is the system has H of t. Then H2 of t and H3 of 3 can be replaced by H2 of t plus H3 of t. Now these two are connected in cascade, therefore H of t, this entire thing, let us take H of t. H of t is equal to H1 of t convoluted with H2 of t plus H3 of t. Now here x of t is input and y of t is output. Output y of t is equal to x of t convoluted with h of t, where h of t is nothing but h1 of t convoluted with h2 of t plus h3 of t. Now let us solve some problems. Find the overall response x of t in terms of the impulse response of the system, each subsystem for the system given below. Now let us take here, if you see h1 and h2 are connected in cascade, h3 and h4 are connected in parallel. So we can simplify this one. H1 and h2 are connected in cascade, therefore x1 of t convoluted with x2 of t. x3 and x4 are connected in parallel, therefore x3 of t plus x4 of t. So these two are given to a summer with here plus and a minus, therefore x1 of t convoluted with x2 of 3 minus h3 of t plus h2. Then here h5 of t. These two again are connected in cascade, therefore this entire thing in convoluted with h of t, and output y of t is nothing but x of t convoluted with h of t, where h of t is this one. Now let us solve another problem. Given h1, h2 and h1 of t and h2 of t and h3 of t and h4 of t be the impulse response of an LTI system, draw the interconnection of the system. Draw the interconnection of the system. Draw the required to obtain the overall impulse response. So there are two ways of asking the question. First way is they'll give the block diagram and you have to write the impulse response. This is the other way of asking a question where impulse response is given to you and you have to draw the block. Overall transfer function impulse response will be given to you, expression will be given to you, and you have to draw the connect. Now if you see, this will first, this addition operation is there and a square flower bracket is there. We'll remove this one by addition. Addition is removed by connected in parallel, therefore h2 and h3 h4 let us connect in parallel, so that these are connected in parallel and all are in between plus, therefore we are given to plus. Now these parallel combination is connected as h1 of t is in cascade. Either you can connect here or there, because convolution property is commutative. So h1 of t, here parallel combination gives x of t and y of t as the output. Now let us discuss the properties of an LTI system. Here, first property let us check is memoryless system. Now let us check whether the given system is a memoryless system or a memory system, or in other words, memoryless system is called a static system and memory system is called dynamic system. Here, if you see, a system is memoryless if its output at any time depends only on the present value of the input. This is true for discrete time. If you take the discrete time system, LTI system, only if h of n is equal to 0 for n not equal to 0. You should remember this expression, h of n is equal to 0 for n not equal to 0. So for n equal to 0, the system impulse response output should be there. Other than n equal to 0, you should have the impulse response as 0. Then only the system is called memoryless. And for LTI system, h of t equal to 0 for t not equal to 0. Only for t equal to 0, you should have h of t as some value other than t equal to 0. Let us say for t equal to 0, 1 2 3 4 or minus 1 minus 2 minus 3. If you substitute that value, h of t should be 0. Then only the system is memoryless, otherwise it is called not memoryless. Now let us solve some problems on this. H of t is given as 5 into delta t. Now how to verify whether this depends on the only t equal to 0. Now where delta t is nothing but impulse response. According to the definition of the impulse response, delta t is equal to 1. Delta t is equal to 1 at t equal to 0. Only at t equal to 0, delta t equal to is 1. Other than t equal to 0, the system is 0. Therefore, h of t, for t equal to 0, h of t will be 5. Other than t equal to 0, let us say 1, 2, 3, h of t equal to 0. Therefore, it satisfies the condition h of t equal to 0 for t not equal to 0, then the system is memoryless. Now let us see another case. H of t is equal to e raised to minus 2t u of t minus 3. Now let us sketch. Here e of minus 2t is nothing but an exponential decaying signal like this. That signal multiplied with unit step response here, where it starts u of t minus 3, where it is will be 1 from 3 u t equal to 3 to infinity. Therefore this signal, other than if you substitute t equal to 4, then for that system this is 1 and this is e raised to minus 2 into 4. This is e raised to minus 28 into 1. So it is a non-zero value. Therefore the system is memoryless. The system is not memoryless, or the system is a dynamic system, or in short you can call it is a memory system. Now let us take another example. H of t is equal to e raised to 5t u of t plus 2. So as we know that without checking this one, you can directly by checking this one only, you can say u of t plus 2. T plus 2 is equal to, here for minus 2 to infinity, this is u of t plus 2 is 1. Therefore for t equal to minus 1 minus 2 till infinity, the t value is 1. Therefore it is not non-zero value. Therefore h of t is not equal to 0. For t not equal to 0, then the system is not memoryless. Now let us see another example. H of n delta n plus x sine n into pi. If you observe at this stage, if you observe here, it is a discrete system. So where n is nothing but only integral values of n, it will take, it is 0 1 2 3 minus 1 minus 2 minus 3. Only it can take integer values. It cannot take any between values, right? As we know that delta n is a memoryless system, because delta n exists only for n is equal to 0. For n not equal to 0, it is 0. Therefore, now let us check this one. Sin n pi. Let us take n is equal to 1. What happens if you take n equal to 1? Sin pi. We know that sin pi is 0. Sin 2 pi, it is 0. Sine of minus pi, let us take n equal to minus 1. Sine of minus pi, it is 0. Sine of minus 2 pi, it is 0. Therefore, for all the values of n, for integer values of n, or the sine is sine value, sine of n pi is 0, or sine, for a sine, integral multiples of sine pi is nothing but 0. Therefore, sine of n pi is 0 for all values of n. Therefore, the system h of n is equal to 0 for n not equal to 0. For any value of 0 n, the system is here, it is 0 only, except at n equal to 0, then the system is memoryless. Now let us take then another example, fifth one. H of n is equal to 1 by 2 whole raised to n, u of n plus 0.02 whole raised to n, u of minus n. Only if this, in this problem, only if this would have been asked, then the system is a memoryless. But here, if you observe u of n minus 2, where it exists from 2 to infinity. Therefore, for not h of n is not equal to 0, for n not equal to 0, the system is not memoryless.